First of all, this talk is about the any mobile application, and you can apply this architecture to any mobile application or even front-end application. But generally, for this talk, we stick on Android, and we just walk through the modularization in Android, and let's see the challenges and best practices in this work. So, short introduction about me, and I'm Alireza Tizfahmfard. I have been developing Android since 2013, and in the last 2 years, I'm working as a senior platform engineer in Technocion on Get Contact application. You can find me on social media and on Twitter with this handle and LinkedIn. So let's first talk about the application. I want to bring example about that, and the application is Get Contact with more than 5 million users around the world, more than 70 countries, and that application has features some caller ID, spam blocker, telco, contains like AI assistant, second number, and end-to-end chat, and generally is a super app for communication, and you can communicate with any kind of communication with this app. So let's talk about our problems. And when you're developing this application with a large amount of users, you will have more problems rather than the normal and small applications. And some of our problems start from this area, from the merge conflict, build time, and dynamic feature delivery, and shared code. So let's go each of them and to see what was our problem. And in merge conflict, we had a lot of problem to merging our branches together, because when your team grows and you have 20 developers, 30 developers, you need to organize the classes in correct way and just make sure you do not miss any code in merge conflict or in release time. The next problem we had was a build time issue. Sometimes the Gradle build time takes a lot, and it was just the main problem of developer experience, and that affect the performance of the also feature delivery. Because, for example, when you want to just change some button, or I don't know, just change some function, and just to see the result in the next round, you have to wait more than usual. And in long cases, for example, clean build, it takes more than 50 minutes to see the result. So the next thing is not a problem, is just a requirement to be flexible at scale, which is the dynamic feature delivery. With help of dynamic feature delivery, you can deliver a specific scope of your application to end users. It supports just localization, or based on the CPU type, CPU architecture, or based on device density, like for tablets or for mobiles. And with just this feature, you can have a short and a small bundle size, and you can download it at the runtime, your features. And the next and last problem today I want to talk is a shared code. Shared code is just a problem of the maintainability of the code. That means, for example, we want to share one class or one utility function around our code base, but we have to make sure this implement in the correct way, and it's testable. It is not a feature included, and it's a generic enough to respond and answers to any usage of that. Like, for example, navigation is kind of shared code. Like caching is kind of shared code. So for solving this challenge, we discovered many solutions, but with the one main goal. The main goal is that each team should be independent and autonomous to deliver their feature. So for that reason, we need to improve build time. And build time is affect the development time, and if we just improve this part, we achieve we increase the developer feature delivery velocity. Next thing is reusability and maintenance, and like providing the shared UI kit for rest of the application, or same navigation behavior for every feature. This is one of the goal we want to achieve it with the reusability and maintenance. And the next one is bundle size. Bundle size is crucial for us because we cannot just bundle all of our features for every country in the world. For example, we have a telco feature. Telco is just available in the USA, and we just want to release that feature in that area, and we do not want to include that feature in our bundle size and release it, for example, in Europe. And the last part is developer experience and robust application from users' perspective. And users always should see same behavior of the navigation or same filling of the button or text field around the application. And it's points to the related about the reusability and maintenance. Okay, so in that case, we find modularization is good for us. And let's first talk about what is the modularization. Just modularization is so basic concept of the software development, and modularization is just breaking down your feature, your function, your class, your product in a small, meaningful piece of code, and you can put it in one package and you can call it as a module. So what's the advantage of modularization? The first advantage is code organization and maintainability. Organizing code into logical units make it easier to navigate and understand each code base and each module. And with that package, you just focus on a specific functionality and make it easier to just update the code and find the dependency of your code without affecting other parts of the application. Reusability. Modular components can be used across different projects or within the same project. This improves efficiency and avoiding code duplication and reducing development time, and it allows for consistent implementation and behavior across multiple projects. The next thing is collaboration. Modularization enables parallel development and collaboration among team members. Different developers can work on separate modules without the conflict, as long as they have an interface between modules, and the interface should be well defined. And the next thing is testing. Testing is with modularization, individual module can be testable and can be tested independently, and just focus on the unit, testing their unit without the worry about the other part of the project. The next thing is scalability of the project. When modular architecture provides a foundation of a scalable application, and a new feature or functions can be added during the time without the worry about the infrastructure of your application. For example, if you want to add a new feature to your app, you should not worry about the networking layer or which UI component should you use, and you need to focus on the feature and the behavior of that feature. And decoupling, and based on one of the famous principle in the world, solid decoupling, is just if you want to have a maintainable code, decoupling is one important part of that. And also, if your code is decoupled and encapsulated in a small amount of functions and classes, and you have a better code quality. And in the last item, you can deploy flexibility. And it means you, just like a dynamic feature, we aim to add it to our application. We can deploy our feature based on requirement or based on some condition on a specific region. Like everything in software, there is no silver bullet for just everyone. And modularization also has some disadvantages. One of them is just over modularization. Like it's possible to over modularize your application. Like result will be massive number of module and files, and increase the complexity of the project without the helping to that. The next thing is the initial overhead. And if you are working on a monolith app, and it needs effort and time to prepare infrastructure and prepare a foundation for migrating from monolith app to modularized app. The next thing is complex dependency management. Dependency management is a little bit risky, because if you do not care about that, you will face about the circular dependency, or if you set a foundation of the architecture not clear, you will have a complexity of how you can communicate between features, how you can communicate between your modules, and it causes some problem if you do not care about that. And communication between modules it should be defined clear, and based on their interface, they should just expose essential functionality to other modules. And if you do not just think about that and ignore this part, you will have a problem in implementation of the modularization. And this is just we covered in the advantage of the modularization, and also it's a disadvantage, because all of your unit module works perfectly, but when you connect each of them together, you also should write an integration test for most of them, and write an end-to-end test for most of them, because maybe one module and two modules can work independently without problem, but when you just connect it together, you will encounter with some problems. And the last part is a learning curve. Modularization just may introduce new concepts and new design patterns, and the developer will be those developers are not familiar with that. They need to just take some step to learning about that. So let's talk about which modularization way is better for achieving these goals. Modularization by feature or by layer. One of the most controversial things in Android is just or any mobile application is, should we modularize our application based on layer or based on feature? All days, like we had one app module, and inside of that app module, we separated our app based on presentation, domain, and data layer. And imagine we are using clean architecture for that. However, this approach does not just answer to our needs when you want to scale your project, and when you want to work in parallel among like 20-30 developers on the same project. So based on some objectives, we can measure which one is suitable for us, and we can consider it as on our way. And just with the feature modularization, you have a more freedom, and you will get a more opportunity to develop your feature rather than layer modularization. For example, if you have a one data layer for rest of the application, if you change one class inside of that layer, your application needs to build again for domain layer and domain layer for presentation layer. But imagine you are working in your team and you want to change one feature in your product, and why other teams need to just build your feature when they do not want to that. And this is just this point just exactly mention feature modularization just rather than layer modularization. So until here, we learn about the modularization and advantage and disadvantage of that. And so we need to have a guideline to walk through this path and learn about the challenge and how we can solve our challenge in this way. So for that reason, we built this this hierarchy of the modules and this guideline for building our modules. I will start from the library module. Library module is are simple, and it's a just essential part of the shared code. And for example, like your UI kit system or your cache system is kind of the library module, and you want to write it one time. And usually you can think about that library module can be open source, and you should not write any business logic or any application behavior inside of that, and you need to just communicate with OS or communicate with the like, for example, for caching, maybe you want to write in the file or you want to write in shared preferences or database, but you do not want to just be involved in your feature layer, and you can write it inside of the cache module and encapsulate it in there, and you make sure your cache module is ready for everyone. For example, I bring three type of the R modules, and one of them is navigator. Navigator does not have any clue about the features, and it's just a URL management system. We just give a URL to that feature, to that module, and library navigator in library layer tries to find the correct screen for us and return the fragment or composable for us. UIKit is our design system module, and we define all of the theming, colors, typography inside of that. And when we want to just update our design system, we just go to one module instead of just going to rest of the application and try to find the all usage of one buttons or finding the which component uses dark theme or light theme. And in one place, we can manage all of them. Or caching also, like I mentioned in the previous slide, it contains the key value structure, and to be save and get the data with the same interface across our features. So we learn about the libraries and what kind of the module can be library, and when we create a new module, what we should do, what we should put inside of the library layer. Next part is plugins. Plugin is just a cool concept for sharing the code. And plugins usually is a small pieces of the code, and you want to share across your application. Let's imagine this scenario where you have a remote config, and that request will use throughout entire of the application. The initial approach probably will be just implementing that remote config in each module, in each feature. And this is a good approach until your remote config will change. And in that case, you need to just again go to each of them and, for example, replace one model or replace one parameter you want to send your backend or get from your backend. Or if you are using third-party services, for example, Firebase, and if you want to migrate it to the another service, you need to refactor each feature. However, with plugin, you can encapsulate it inside of the one module, and you can implement all of the logic inside of that. And like a plugin, you can plug it to any feature you want. And always you make sure your logic, your behavior is consistent for across the application. Like this config, for example, you want to send a request to the backend to get the data, make sure all key encrypted and save data in cache, and expose a specific key or a specific value to the feature. And if you want to implement it everywhere, you will have a code duplication. And if you want to put it in a library, it does not pass the requirement of the library because it contains the feature related stuff. The another thing is permission, and based on this diagram from developer.android.com, and it is a recommendation diagram from Google, and Google just recommended this way to show a permission to user. And imagine just one scenario, you want to just show a simple permission to user and to your user, and you want to make it repeatable in entire of the application. It's really hard to manage it if you have just 50 or 60 pages in your application. So until here, we covered libraries and plugins, and next part is our feature modules. Feature modules are a small part of our application. Usually they contains UI logic, data logic, and domain logic, business logic. Based on their product behavior, they can behave. And for this concept, we are using clean architecture and this diagram, but you can use any architecture inside of the feature module until you have a clear boundary between your module and module outside of your module. And we walk through about each layer and how the other module can improve our code in each layer, for example, data layer or domain layer or presentation layer. So in data layer, and usually based on this diagram, we have a data models can be entities for database or can be just DTO from backends. And also we have a data sources, and it can be cache layer or REST API client or DB client or any client you want to get the data from that, and repository to managing all of them to providing like offline first experience and just mapping the data inside of the repository and preparing the correct data to the next layer. So in that case, because you have one solid caching library in entire of your application, you can use it without writing again that layer. And you, for example, in that feature, you can use local cache provider and memory cache provider, and this is a shared class across your application, and you can put data in one module and you can get data from another module. This is really helpful when you want to share a small piece of the data and you do not want to just hold a big object or a heavy response in your cache layer. The next layer is domain layer. Usually is simple, and it contains model, your business model. Because of the clean architecture, you need to be independent in domain layer, and for that reason, you need to just place models in this layer. And use cases are implementation of your business logic and encapsulated based on your language, whatever it can be, Java or Kotlin. And in that case, for example, you want to send a request or managing some repository or orchestrating data from some repositories, but this behavior should be come from your backend. And in that case, because you already have a config client, config was your remote config response, and you do not have to write it again, and you can just inject that class and use it without any problem, without any worry about that this class what it's written. It always does its jobs, and you focus on the feature. And the next layer is presentation layer. It's the really good part for including modularization, because with this approach you just write a more or less code in presentation layer, and you just use utility from your modules. And in this scenario, imagine we have a module for sending our events to third-party services like Firebase or any analytic SDKs, and we want to show a toast or dialog to our users, and we want to show a permission to our users. We need to navigate between two pages from our feature module. In that case, we just needed to inject uh, the all plugins or all libraries we want. For example, in that case, we wrote all event behavior in one module, and we just expose an interface, and this feature module just get that interface, and regardless what is the implementation, it can calls that interface and send the data. And it applies for also MVI and Navigator. So until here, we learn about the features, and now there is a one rule for just feature modules. Feature modules should not be depend each other, and all of them should be independent because of the circular dependency. So if we cannot communicate between two features directly, and we cannot navigate between two pages or share data between two pages or two components, then how we can communicate with that part? So the next part, in that case, we will go through coordinators. First of all, let's clear what we want to from coordinators. And coordinators are responsible to communicate between features, and they should handle navigation, data source, shared business logic, and showing features beside of each other. And navigation already covered in libraries, data source already covered in the libraries because of the cache layer, and shared module, shared business logic already covered in the plugin layers. And the last part is coordinator, how we can show two features or multiple features in one screen without the knowing about the what is that feature and what is the next feature beside of that. So imagine this scenario, and this is 5 features from our app, from Get Contact app, and the left side, the left top is who create my profile, and bottom of that is an AI assistant, and the next center is eSIM and my tag and business account. So in that case, we needed to just set up all of them in one page and create a dependency graph for all of them and showing in one page. That page can be composable, fragment, or activity, or can be Android view. We just needed to put these features beside of each other. So in that case, we just need to define one new module and add our dependency to that. For example, we call this screen as a feed, and we implement that screen inside of the our parent module. In that case, parent module is root module, and we include our features: eSIM, AI assistant, business profile, my tags, and so on. With this way, coordinators will be holder of our features, and they do not care about what is the feature as long as they have a same interface as other features. So in that case, it's just a short diagram about the screen I showed before, and when you compile it, it will be like this, and when you run it, it convert to the one screen. And with the help of the component-driven principle, you can just be component agnostic. It means your feature always will be same as other features. from coordinator perspectives, and coordinator can replace it based on some conditions. Imagine you want to implement A/B tests, or you want to implement server-driven UI, or you want to just implement the localization based on some regions. For example, in USA, you want to show a one feature, or in South Asia, you want to disable that feature. And the coordinator module is responsible to that, and with just replacing one feature to another feature based on their logic, just communicate between features. So we covered about the coordinators, and we learned about the what are coordinators. And the next thing is launchers. So now we have a libraries and plugins and features and coordinators. Now we need a one application builder and one launcher for launching our app. It's just imagine it's like you build small parts of your Lego, and you want to just build it together and make your model perfect and complete. And for that reason, you can define one launcher. And the benefit of launcher is that it boosts development speed and developer experience. How? With the help of the demo app. For example, you have a social team and you have a core team. And core team is focusing on feed feature, and social team is focusing on chat channels, live stream, and all of the social behaviors. In that case, you do not want to just build for example, you are working in core team, and you do not want to build the chat features or live stream features, and they are also, you do not want to just spend your debugging time to just pass through those screens until find your feature and starting debugging. In that case, you can define a one demo app for yourself. For example, in that case, I define a feed demo app. Feed demo app contains necessary modules, and because each module develop independently and there is no dependency between each of them, and you can just create a one brand new module, and you can call it your launcher app, and you can develop your application based on that. It's increase your build time it increase your development experience and decrease your build time, and when you are debugging or when you want to develop a new feature. And for production version, of course, you cannot use this approach, because you need to have a one bundle to deliver your app to your user, and you need to just use dynamic feature delivery. And for that reason, you needed to take another approach. So, but in the development time, and it means for us, for developers, most of the our time is developing our application or debugging our application. It's a really game changer to have a better experience. And after you build that screen, for example, in that case, I'm not sure this is visible or not, but it was a long screen, and I tried to make it visible in this screen. But the right screen will be available for you, and the other options is not available for you, because you just other tabs like chat tab or dial tab in the bottom navigation is not clickable. And if it's clickable, it does not navigate to anywhere else, because you just built one screen based on your needs. So, and this is a short diagram about the feed app in the development. You can just use that, and you need to just import the authentication module, which is a plugin type, and config module for managing your remote config response, and just others all are your features and feature related stuff. So let's take a look about the get contact hierarchy and see how it peaks, and why we took that approach, and how we just get a benefit from this approach. So based on this diagram, we just see a short part of the get contact application and see just the feed module in top bottom right is the data screen. I try to cover it, and imagine you want to develop chats, dial, other tab contains like 10 features inside of that, and it's really hard to maintain your application if you do not have a separate layer between your modules, and your app is tightly coupled together, and you cannot just deliver just same behavior to all application because the code maintainability is so hard. So we learned about the launchers, and this is the last part of our guideline about the modularization and how we can apply this pattern to our applications or any application. And this is a get contact journey. We started from 5 modules, and then we right now we having more than 50 modules or something less, something more than this amount, and we try to divide it in meaningful piece, and just to also we consider to do not over modularize our application, and just modularize based on scope and based on what we want. So we have a one article about that on Medium, and also we implement the one project, and you can find it in GitHub on GitHub. And this is not full implementation, but it gives you idea about the implementation and how we can approach that. Thank you for your attention. This is the end of this presentation, and I'm here if you have any question, or I will be happy I can answer you.
Thank you so much, Ali, for that insightful presentation. I learned a lot, and we have a few questions because we have approximately 15 more minutes to go. So I'll start with the first one.
Sure.
Ryan asked, do you try to concentrate testable logic code in specific modules and cover those modules with tests?
Yeah, we tried that approach, but that approach does not work for us, because usually when you separate your logic in a testable module, in a separated module as a just business logic, it can cause some problems when you want to share that code. And we just try to make one module completely in one scope, and try to test that module and to cover the behavior of that module, and then top of that we write an automation test, integration test to connecting each module and make sure our application is working perfectly. I'm not sure I could give a correct answer to that or not, and if it's not, please just elaborate more your question, Ryan.
Okay. He had a second question. Do you find that sometimes duplicating code across modules is better than attempting to abstract it to a specific module, or just always try to abstract?
No. This always one of our rule of thumb. It was like that. The first thing is just apply your code in one module, and the second time again apply it in your module, and it can be code duplication, and it's totally okay. And after third time, we just realized, okay, this is a repeatable behavior, and we can create a one generic way for that. And for example, one of our learning case was error handling, and each module implement their error handling, and after we find we learn how they implement their error handling, we create a unique way, and it's not abstract way, and it's a just utility way to just give some tool for developers to implement their error handling and to make sure we do not just create a boundary around the our features. This feature is so abstract and not. We just try to go with the utility function and as much as possible.
Okay, thank you. We have a question from Simon. What do you think about when you have over 500 to 600 modules after breaking the code into small parts? Do you think that will make the gradual build longer?
Of
And
course,
also,
go
sorry.
ahead.
And also searching for the file in another module harder.
Yeah, of course, that amount of the module makes a gradual build time longer, and this is one kind of the over modularization. And if you want to just have that kind of that level of the modules, and you should just use other patterns like dynamic feature delivery to deliver your feature over the runtime rather than just compiling your feature in the build time. About the project hierarchy and file behavior, absolutely, it takes a longer if you want to search your module. But for preventing that approach, you needed to creating multiple repository for that. And for example, in our example, in get contact, firstly we created one module in get contact source in get contact repository, and after it takes time, we decided, okay, it's enough for this project, and we need to grab all of the code from the get contact repository and put it in another repository, and with publishing by Maven, and we get a new version in our project. It means this library is internal and it is not in one repository, and we can just update our project based on our need whenever we want, and it helps to navigating through files in one project.
Okay, thank you. Jen asked, what's your perception on having both use cases and repositories? In most cases, don't they usually have the same duplicate code?
Can you more elaborate about that?
I have always seen that it's not in most complex applications. When you inject a repository within a use case, the only thing you do is invoke the function that was within the repository. So you end up having the same function written in both the repository and the use case without any other improvement. So is it necessary to have both?
Absolutely, a great question. And based on just Google recommendation, this is optional. Also, in our case, we make it optional. But for having same consistency and across our application, we usually cover that. And also because our use cases, because our needs, usually we do not work with single repository. We have a multiple repository in our use case, and in that case, we try to create a chain request or just getting data and waiting for the next data and something like that. And for our case, was useful, but it's optional. If you do not have a business logic in your client, you can just skip that part.
Okay, thank you. This person asked, I can't pronounce their name. What do you suggest? Start a project like a single module application with the possibility of splitting in the feature, or spend more time on setup and modularization from the start?
That's a good question. It depends on your team and your product. And if you have just more than 3 developers, 4 developers, it's a good time if you want to start your application to make it modularized. And if your application does have like 12 screen, 30 screen, or it's more, you should consider modularization. But if you are just a startup in the start point of your application and you do not have this facility, and just keep with single module and just try to write your code as encapsulate as possible to help you in the future. You can just migrate your code to another module and place your code to another module to be to be continue your modular way.
Okay. They also had another question. How do you organize communication between different features that are not included in one coordinator?
This is a really good question, and usually we try to encapsulate our features inside of the one coordinator. If it's not that one, we need to communicate with the navigator. And for example, if you go with the two big coordinator and each of them should not be included in another, we just navigate between, for example, one activity to another activity, one screen to another screen. We just with the help of the URL system, URI system, we go with that, and we try to just make sure we do not share big data between features and between coordinators. And in that case, Navigator is helpful for us.
Okay, last question. How do you handle features like a home screen that combines several features? The home screen is its own feature module, but I want to reuse some functionality defined in several other feature modules.
Yeah, it's a good question, and I try to cover it, but I try to just summarize it. Like feed screen I showed is our home screen, and in that screen we have like around the 10 or 12 cards. It's a totally dynamic, and based on the region or based on some condition from server, we can show and hide that feature. So in that case, to just having this flexibility and this just capability, we implement each logic inside of the features and make that homepage as a coordinator, as a connector. It does not have any idea about the functionality of each feature, and we make sure our feature is reusable inside of their code. And it means we just need, if imagine currently you are showing your feature in homepage, and tomorrow you want to build another page, and you want to show same feature in that page, and you just need to inject your feature in there, and without any complexity to about worrying about this feature should be take care of this business logic or that business logic, and coordinator is usually covering that part.
I have a follow-up question. Does the coordinator have a view model? Is it that the view models communicate, or within the coordinator do you just add the composables of the other small features?
For sure. It depends on how big the coordinator is, but usually because the coordinator is manager of the features and it needs to manage the estates. For example, if you have two features and one of the feature has a close button, and when you press it from the coordinator, for example, like one card should be closable, and you should save that state in your view model, save the UI state, and to make sure you do not show it again to your user. And in that case, coordinator needs to have a view model. Or if you needed to just connecting some plugins, like for example, in the newsfeed in homepage, it is so common to use this practice. You want to show a permission and config, and also other shared code, and config comes from another module, and permission also comes from another module, and you want to connect in one place, and that place will be your coordinator, and you can put it in your view model, or you can create a one use case for your coordinator and inject that use case inside of your view model. Both approach works.
Okay. The last thing is just to appreciate the presentation. Yeah. Thank you so much for joining us, and thank you for the audience for being interactive. We'll be right back in the next 10 minutes for a session with Maya on imperative, declarative, object-oriented, and functional for of a Kotlin kind. So, yeah. Thank you, Ali.
Thank you so much. Have a good time.
You too.